Hi, I'm Dr. Raj Shah, and I'm back with another math mystery for you. This is a really fun one that anyone can do. You will need a pencil and paper to do this along with me. So please pause the video now, go grab yourself something to write with and a piece of paper, and come back. I will wait. All right, what we're going to do is we're going to draw one continuous curvy loop that crosses over itself a little bit, but always goes back to where it started. Think about drawing this without picking up your pencil from the paper. Let me show you an example. I might draw a shape like that. You see how it comes back there at the beginning and closes off the loop. So I have this one loop, but it does cross over itself a little bit. Something fun like that. Not too crazy, but definitely want to have some intersections and things like that. Now we're going to analyze this picture and we're going to discover the mystery. Here it is. First thing we're going to do is we're going to count the number of intersections, where the line crosses with itself. So I'm going to mark those. 1, 2, 3. I don't think I have any more. And I'm going to write that down on the side, that I have 3 vertices. We're going to call them vertices. Okay? So I use the letter V to abbreviate that. And then the hardest part of this is we're going to trace around and count how many edges we have. An edge is going to be part of the line that goes between two dots or comes back to the same dot. So in order to get these correct, you want to make sure you're starting from a place and then kind of keeping track what direction you go. So I'm going to start from this vertex and go in that direction and then go all the way around tracing my edges until I get back to where I started. So this first little segment there, that is my first edge. 1. And then up to here is 2. And then to there is 3. And then keep going in the same direction. Around this little circuit here is 4. Back around this way is 5. And then back to where I started is 6. So my diagram, if I've done it correctly, which I think I have, has 6 edges. Which I will write there on the side, edges equals 6. Okay, last thing, we're going to count the number of faces. A face is just a closed section of the picture. So here's one. This little part right here is another one. This section through there is a third one. And then this one, even though it's inside of this one, we're going to count it, is another one. That's 4. And then here, I won't count that because that goes out into the universe. So that's not its own section. So I believe I have 4 faces. Now that you have these 3 numbers, I want you to add the vertices and the faces together. Add those 2 numbers together. And then subtract the number of edges. Now, if you've done it correctly and counted everything right, I am 100% sure that you are going to get 1 as your answer. Certainly for my picture, I do. If I add vertices and faces, that's 7. Subtract my edges, that's 1. Now, you have your example. I have my example. It could just be a magical coincidence that we both got 1. Or it could be that this is always true. So the first thing I want you to do is draw a few more of these and check, indeed, if V plus F minus E is always 1. If it is, then I want you to go a step farther and figure out why. How is this possible? It can't be magic. It has to be math. So I want you to explore that, and I will be back with a short hint if you need it.